This is chapter 4.1, exercises 1 through 24. This section has to do with arc length, radians, and we're going to go through the problems, the odd number problems here. Convert from DMS to decimal form. First of all, let's look at what DMS. We got an angle. DMS stands for, D stands for degree. M stands for minutes. And S stands for seconds. And here's where we're represented. We have 23 degrees. And we have 12 minutes. This numbering system that we use for angle measure with degrees, minutes, seconds came from the Babylonians. Had to do with 60 base numbers, and the utility of 60 base numbers is that the number 60 is divisible by 2, 3, 4, 5, 6, 10, 15, 20, and 30. So that gives quite a variety of fractions that are available using those numbers. Anyway, it's kind of, this degrees, minutes, seconds thing is kind of analogous to hours, minutes, seconds, in that in 1 degree, is separated into 60 pieces. That's in 60 minutes. I'll just abbreviate minutes there. And 1 minute is separated into 60 seconds. And if we want to go straight from degrees to seconds, we have, it's just like how many seconds do we have in an hour? Well, 60 seconds times 60 minutes would be 3,600. So 1 degree equals 3,600 seconds. And so we're going to use these identities and getting a decimal form. And so for 23 degrees, 12 minutes, what we have is we have 23 degrees. That's going to be quite easy. Plus, what we want to do is take this 12 minutes, and I'm just going to write out MIN. Might be more obvious. And we're going to multiply this 20 minutes by the conversion factor related to minutes and degrees. Well, here we have 1 degree equals 60 minutes. And so what do we have to place down the denominator to cancel this minutes up here in the numerator? Well, it's going to be, we have to put 60 minutes down here. And up top we have degree. So when we cancel out our units, our minutes over minutes cancel. And to simplify, we're going to have 23 plus 12 over 60. And what that's going to be, it's going to be again in degrees. It's going to be 23.2 degrees. And just to be sure, we can go to our calculator and put in a 23 plus 12 over 60, and there we have 116 over 5, improper fraction, and we'll simplify in decimal form to 23.2 degrees. So that is our answer, which we box in as correct. Next, under problem 3, convert from DMS to decimal form. Well, it's going to be the same process as we had before. So we're going to have 118 degrees, and we're going to have plus, we take this 44 and divide it by 60, since there are 60 minutes in a degree, plus we have 15 seconds, and if we go back to our little identities beginning, we have 1 degree equals 3,600 seconds. So we can multiply this by, we need to cancel seconds, so we put 3,600 seconds in the denominator and 1 degree on top. So seconds over seconds cancel, and what we have left is 118 degrees plus 44/60ths of a degree plus 15 over 3,600, and that's going to be in degrees also. And what that is going to be equal to is going to our calculator. We have 118 plus, we have, make sure I remember what it was, 44/60ths plus 15 over 3,600, and we get this improper fraction, which decimalized, enter, we get 118.738. So 118.738, and that's going to be in the units of degrees in decimal form. Next, the next set here, 5 through 8, has to do with converting from decimal form to DMS, 2 degrees milliseconds. So we're going to use the same conversion factors we did for problems 1 through 4, but working the opposite direction. So for this, we have to convert to degrees milliseconds. We're going to have 21 degrees plus 0.2 degrees. And we want to, I'm going to write this, DEG for degrees. And we want to convert these degrees to minutes. So we have 1 degree is equal to 60 minutes. So when we multiply this out here, this 0.2, to cancel degrees, we have to put degrees here in the denominator, offset this degree up here in the numerator, and we put 60 minutes on top. And then we have a cancellation of degree over degree, so our correct answer is going to be 21 plus, it's going to be in degrees, plus 0.2 times 60 degrees. And that's going to be equal to 21, excuse me, I made a mistake here, didn't I? I said degrees, I meant to put minutes here, the second term of minutes. So we have 21 degrees, 0.2 times 60 minutes, which is going to be 12 minutes. So that's going to be our answer. And next we go on to problem number 7. We have 118.32 degrees. Well, the 118 degrees is going to be quite simple. We just bring down this 118. And then we're going to have these 0.32 degrees. We take the 0.32 and multiply that by 60, just as we did in problem number 5, and that's going to be the number of minutes. So that's going to be equal to, bring down 118 degrees, and 0.32 times 60. So going to a calculator, 0.32 times 60, we get 19.2. So this is going to be 19.2 minutes. So we have this 0.2 left over. And so what we're going to do is rewrite that as 118 degrees, 19 minutes, and these minutes we're going to change this 0.2 minutes we have remaining, we're going to change, I'll put MIN for minutes here, we're going to convert that to seconds. How do we do that? Well, 1 minute equals 60 seconds. So we're going to multiply this 0.2 minutes by, well, what do we have to do to cancel out minutes? We have to put minutes here in the denominator. So we'll put a minute down here in the denominator to cancel out this minute in the numerator. And we have 60 seconds here at the top of the numerator. So minutes over minutes cancel. And what we're left with is 118 degrees, 19 minutes, and we have 0.2 times 60 seconds. 0.2 times 60, that's going to be 12. So that is our answer. I want to point out something, that sometimes when you work these problems out, you can possibly end up with a decimal point after the number of seconds. Let's say we had 118 degrees, 19 minutes, and 12.5 seconds. Well, what are you going to do with that 0.5? Well, the 0.5 has nowhere to go. We don't have a further unit, a smaller unit to take to go down from seconds. And so if we have a decimal point something for a number of seconds, we would just have to leave it in that point something. Next, we have this problem set. Next problem set, starting with 9, has to do with converting from DMS to radians. Well, radian is an angle measure that is related to the radius of a circle. So what you have when you have a circle, like the one I'm drawing here, you have degrees. Everybody is familiar with dividing the circle into 360 degrees. But there's another unit of angle measure that's called the radian. And what that's related to, that angle measure, is to the radius. So it's almost like radius is similar to radian. So you have over here at the left side of the circle, if we rotate from the right as a standard, we have 180 degrees. And that's the same thing as pi radians. And you can kind of think of it like this. The formula for circumference is C equals 2 pi r. And if the radius is 1, well, then the circumference would equal 2 pi. And so pi is equivalent to 180 degrees. And we say pi, we mean pi radians. In these problems, I'm going to put RAD to abbreviate radians. And so this presents ourselves with the identity we need. We have So our basic identity for this is 180 degrees equals pi radians. So we take our 60 degrees and we want to multiply this by this conversion factor from 180 degrees to pi radians. Well, what do we have to do to cancel out this degree here in the numerator? We have to put that degree in the denominator. So we're going to take this 180 degrees and put this 180 degrees in the denominator. And then in the numerator, we have what that 180 degrees is equal to, which is pi radians. So I'm going to put pi rad up here. And we have, as unit cancellation, degree over degree. So what we're left with is 60 over 180, and that's going to be pi radians. And we can take our 60 divided by 180, we can cancel out the zeros and so forth. What we get is 1/3. So we have 1/3 pi radians. And according to convention, this is usually written as pi over 3 radians. And so that's going to be our answer to problem number 9. I want to show you something. The unit circle of trigonometry, which I happen to have up here, you can see in blue certain angle measures in degrees, and in red these same angle measures but in units of radians. Let's go on to problem 11. Problem 11, same type of problem as 9. We have our 120 degrees. We want to convert that 120 degrees into radians, so we multiply it by pi radians over 180 degrees. And as we did in problem number 9, degrees over degree cancel each other. So we're left with 120 over 180 pi radians. And 120 over 180 simplifies to 2/3. So we're going to get 2/3 pi radians, which is the same as 2 pi over 3 radians. So that is going to be our answer for problem number 11. Okay, next on our problem 13, we have 71.72 degrees. So we're going to convert this into, again, radians. So we take our 71.72 degrees and we convert to radians by multiplying by pi radians over 180 degrees. Now, when we take our 71.72 over 180, and by the way, I forgot to cancel degrees over degrees here. Now I do that. And so we have 71.72 over 180 pi radians. Well, in this case, in 71.72 over 180, we do not have a really good looking rational number for a fraction. And so in this instance, when this happens, we just have to multiply out, or it just makes more sense to multiply out this 71.72 times pi, the number pi, and then divide by 180. So let's go ahead and do that. We have 71.72 times pi. We get the pi symbol here, And all this we're going to divide by 180. And we get 1.25175 radians. Now, in this instance, it's very, very important to write down some kind of unit that communicates that the units are radians, because there's no pi. A lot of these angles, like if we look at problem 11, we have our answer 2 pi over 3. If you have a pi in the answer, that's likely going to be an angle measure in radians. But here we have to specifically state what it is. So let's go ahead to problem 15. Convert from DMS to radians. And so that's a problem that's very much like what we did before. So we have 61.24 degrees, and we're going to multiply that by pi radians over 180 degrees. And so we have degrees over degrees cancel. So we go to our calculator. We have 61.24 times pi divided by 180. So you get 1.06884 radians. And when you think about it, this really should make sense. Because if you look at a circle, like we did in an earlier problem, and just on the circle you measure a rotation of about 61.24 degrees, which would be something the one I'm drawing right there. You can really see that a radian, a single radian, I think is 57 degrees. So we're just a little over 1 radian. So if you think about the numbers, this actually makes sense. Next on our problem, we have this next set, 17 through 24, has to do with converting from radians to degrees. And this time they just give the pi and they over 6 and just kind of state that this is radian. So I'm going to start out by putting pi over 6 radians, and to convert those radians to degrees we have to put pi radians down in the denominator. And looking back earlier, remember we have pi radians, our identity, pi radians equals 180 degrees. So we put 180 degrees up top here. And we have pi radians over pi radians cancel each other. So we have 180 over 6 degrees. And 180 degrees over 6 simplifies to 30 degrees. So that is our answer. And again, if we go back and look at our unit circle trigonometry, we see that in red, this pi over 6 is right in the same place as in blue, 30 degrees. Next, let's go to the next order problem, which is 19. We have pi over 10. So again, we're going to say we have pi radians over 10, and we multiply by 180 degrees, over pi radians. And we cancel out pi radians over pi radians. So we get 180 over 10, and that units are going to be degrees, which simplifies to 18 degrees. So that's going to be our answer to problem number 19. Next, another problem, which is 21. Similar situation. We have 7 pi over 9 radians, and we multiply that by 180 degrees over pi radians, and we have a cancellation available here. We have pi radians in the numerator, pi radians in the denominator. So we are left with 7 times 180 over 9. And that's going to be in just degrees. So, in our calculator, seven times 180, and we're going to divide that by 9, we get 140. So 140 degrees is our answer. Okay, good. Okay, next other problem, it's the last one in the set. 23. Say convert from radians to degrees. So we see 2. We do not see any 2 pi or anything like that. So what that is going to be is 2 radians, which I'll just abbreviate RAD. And just as we did problems 19, 21, we're going to multiply by 180 degrees over pi radians. Now, what cancels out? Well, we don't have pi radians in the numerator anymore. We have pi radians in the denominator. But we do have radians. So radians over radians cancel each other. And so remaining we have 2 times 180 over pi. And I guess it could be written, if you wanted to, you could write it as 360 over pi degrees. That's degrees here. But typically when you see this, you go ahead and put it in a calculator, and you're going to get some kind of an irrational number. But here goes. You get 360 over pi. We get 114.592. Okay, that's going to be in degrees. So these have been our odd number problem in the set. I'll go ahead and flash ahead to problem 24. It's going to be converting 1.3 radians to degrees. Well, good luck with the remaining problems in this set, and as always, thanks for viewing.